G'day, Chris here and welcome back to ClickSpring. I mentioned in the previous video in this series that I'd like to try out a final finishing step for this project. These 5 support components are an excellent canvas for some horological style engraving and a great excuse for some more practice. Now, I've already run the designs a couple of times on some scrap practice plates in preparation for committing to the actual workpiece and to get a feel for what works best within each space. It looks like those designs have been approved by the quality control inspector with just a few minor changes, so I think we're good to go. Inside the mechanism, there's an opportunity for some simple symmetry across 2 of the 4 support plates, while still displaying a coherent theme across all 4 plates that's in keeping with this style of engraving. Externally, there's the support arm. Because of its slightly larger surface area and its prominence on the outside of the mechanism, it's well placed to show something meaningful in relation to the device. So, with that in mind, I decided that the engraving should be a long, delicate tendril, unfurling and reaching as it grows, towards what else? But of course the sun. Once complete, the drawing needs to be transferred to the surface of the work, and this method of artwork transfer that I learned from master engraver Lane Zuelke works well. Be sure to check out his video where he describes the method in detail. I'll put a link below. The transfer of detail is excellent, and it's as durable as it needs to be to withstand the constant handling of engraving. A little manipulation in Photoshop maximises the contrast of the sketched lines and also enables scaling of the print as required to match the part. Now, as it happens, these components are quite awkward to hold and are easily bruised by a clamping force. So an excellent solution is this soft putty material called thermolock. It's a temperature-sensitive polymer that softens under a mild heat and can be shaped to whatever's required to secure a given part. Once it cools to room temperature, it's set solid once again, ready for engraving. And with that, the engraving of the suspension arm is complete. The other support plates were engraved in much the same way, which brings us to the best part of any project: final assembly. The sub-assemblies can be bonded with soft solder or by using a modern metal adhesive, as suits your personal preference. I'm using adhesive to demonstrate its convenience, and to show how it avoids the need to manage the heat marring of sensitive parts. The mechanism will receive minimal operation compared to a mechanical clock. Nevertheless, a light oil of the pivots is worthwhile, with the proviso that the oil is limited to the very smallest amount on the bearing surfaces. I've chosen a 1200 grit brushed finish for the plain surfaces, with a light protective coating of microcrystalline wax. The wax doesn't solve all of the oxidation issues, but it does provide a small measure of protection from fingerprints and handling. And it serves as a reasonable alternative to a more involved oxidation protection method, like for example electroplating. And with that, the mechanism assembly is complete. So let's do a quick run through of all of its functions. The movement of both the gnomon and suspension arm assemblies is firm. And there's a good solid click to that day ratchet, with the day indicator coming to rest in the centre of each day window. The indicators move assertively with each day click, firmly holding each incremental step around their respective dials. Which brings us to the various functions of the device. For eclipse prediction, the mechanism is first set to an historical eclipse to calibrate the dials. In this case, I've used the solar eclipse that occurred on the 26th of February 2017. The lunar nodes, sun and moon, are each manually set to their respective positions for that specific eclipse. Then, once reassembled, the device can be wound back into the past, or as in this case, forward into the future, to generate eclipse possibility predictions. Once the sun moves into eclipse season, indicated by the silvered section on the solar display, each subsequent passage of the moon past a node represents an eclipse possibility. The first such occurrence is a lunar eclipse, indicated by the relative position of the sun, earth and moon, and confirmed by the phase indication of a full moon. The next indication is for the well-known North American eclipse of 2017. Again indicated by the relative positions of the sun, earth and moon, and confirmed by the phase indication of a new moon. The sun then moves out of eclipse season and continues onward towards the next eclipse season, a little less than 6 months later. The other function of the mechanism is of course as a portable sundial, with 2 simple settings required before reading the time. Using Greenwich as an example, the latitude of the observation, in this case 52 degrees, would first be set on the latitude scale. The gnomon assembly would then be set to the time of year. In this case I've set the beginning of April as an example. The dial would then be suspended and turned until the shadow of the gnomon's dial is cast along the scale, from which the time would then be read. Now the instrument is designed to show the time in unequal or seasonal hours, with a seasonal hour defined as 1/12 of the daylight period. Of course, the length of that hour changes throughout the year, and so the dial rarely corresponds to our modern equal hour time system. But we can get a rough idea of the sundial's performance by checking it against the modern equal hour times that nominally correspond to each of those unequal hour positions for a given day and latitude. In this case for my hometown of Cairns on December the 1st. Assuming the instrument has been correctly set, the indications for sunrise, sunset and noon are exact. But as we approach and then pass noon, first the discrepancy from equal hour time is apparent, and then too a slight deviation from the unequal hour ideal also becomes apparent. As it happens, there's a small error built into the design that seems to have been accepted by the original designers as a reasonable compromise for the convenience of portability. Having said that, it's still quite good at identifying the correct time within that seasonal hour system. And the absence of hour subdivisions on the original device suggests that a small error wasn't a great concern for the owners of the original portable sundials. In any event, my guess is that the appeal of a portable sundial calendar went well beyond its timekeeping and calendar purpose, and was at least as much about the fun of owning a flashy new gadget, much like it is for us today. And in this regard, maybe its existence so long ago means that we haven't really changed that much at all. From a modern home shop perspective, this is an excellent long-term project. It's challenging without being too difficult, and it has most of the elements required for a satisfying project. It's an interesting machine, with much to investigate regarding how the gearing performs its calculation and how the sundial actually works in this portable context. There's a bit of custom tool making to save some money and improve the build result. and there's much opportunity to completely break away from the script and stamp your version of the project with some personal artistic flair. Above all, a project like this tends to bring about something of a step change in both skill and workshop capacity, as all of the various problems that arise are solved. And for me personally, much of what I learned while completing this project guided my thinking in designing the next Patron Series project on the construction of a dial indicator. So be sure to check that one out when you get a chance. Thanks for watching. I'll see you later.